All right, so the next unit is on something called trigonometry. And in trigonometry, what we're going to be doing is we're going to be working with right triangles. And we're going to be finding missing angles, so the measure of angles, as well as the measure of the length of sides, right, with a right triangle. All right, so the first lesson is on something called the tangent ratio. All right, so it's a ratio between two sides of a right triangle. Now, the first thing I want to go over is the sides of a right triangle. So you have hopefully seen right triangles before. I believe you have. And so, yeah, with right triangles, the key thing here is that there is a right angle in the triangle. Right? So the right angle, again, is 90 degrees. And it's indicated on the triangle by the square, by a square mark. So this here indicates that that angle there is 90 degrees. Right? So in other words, it's what we call a perpendicular angle. So first thing we want to do is we want to be able to label sides. The first side that's most important is the side across from the right angle, which is called your hypotenuse. Okay, so this is the first angle, well, sorry, the first side that you want to label. So always go across from the 90 degrees, and it is your hypotenuse. So the hypotenuse again is always across from the right angle. And as well, since it's across from the right angle, the 90 degrees would be the largest angle in the triangle. So therefore, the hypotenuse is always going to be the longest side. Okay, because, yeah, so if you have a 90-degree angle in a triangle, it's impossible to have an angle that's bigger than 90 degrees. So that's your largest angle. Therefore, the side across from it will always be your longest side. Now, the other two sides that you may or may not have heard of before, they depend on which angle you're actually working with. So let's say, for instance, you're asked to find this angle here, the red one. Then you would label the side across from it as the opposite side. And you would label the side next to it as your adjacent side. Which hopefully makes sense, right? Opposite across from, so, and adjacent next to. Now, that being said, if, for instance, in this diagram, instead of finding this angle, I was trying to find this angle over here in green, then this side over here, which is adjacent side for the red angle, is actually becomes the opposite side for the green angle, right? Because it's across from it, and this becomes the adjacent side. Okay, so that's one of the key things that you need to realize is that the opposite and adjacent side, well, that depends on which angle you're working with. Okay, so right here. Okay, so the opposite and adjacent sides, it depends on the angle that you are working with. All right, so again, notice here that yes, for this, if I'm trying to find this, or if I'm working with this red angle, then over here, this side would be my opposite side. This would be adjacent. If I'm working with the green one, then across from this is my opposite side. This is my adjacent. But the hypotenuse is always the hypotenuse, which is across from the 90 degree angle. Cool. All right, so let's just jump into the first example here. We want to determine the measure of the indicated angle. All right, so this is the angle. I'm going to find the measure of it. So first step, so step one is to label your sides. All right, so what I always start off with is labeling the hypotenuse, which is always across from the 90 degree angle. So this is the hypotenuse. Now, since I'm working with this angle here, check that in. The 8 is my opposite side, and the 3 here is my adjacent side. All right. Okay, so in this lesson, what we're going to be working with are the opposite adjacent sides. You'll find that in all the questions, the hypotenuse is actually blank. But as we go later on in through this unit, we will be working with the hypotenuse side. But for this lesson, it's only the opposite adjacent. So the next step 2, is to set up the equation. All right, so what we mean by that is we need to set up an equation so that we can find this angle here. Now, for this angle, I can call it x, or actually, I'm going to use traditionally this here is called red theta. Right? And it's traditionally the variable used for angles. Right? So as you go on in math later on in other courses, you'll see this little symbol here. All right, it's the same, pretty much the same thing as an x. It's just a variable, but it's the traditional variable they use to for angles. All right, so to set up the equation, I'm just going to write tangent. All right, so this is a ratio that we're going to be working with. All right, there's actually 3 ratios when it comes to right triangles. We're going to be looking at the other 2 later on in I guess 2 lessons from now. The other 2 ratios are going to involve the hypotenuse side. All right, so tangent here, which is the first one we're going to be looking at, is just involves the opposite adjacent side. Right? So the key thing here is tangent is equal to opposite over adjacent. Actually, please forgive me, I'm going to write tangent theta. All right, so what I'm going to do here, in order to set up the equation, all right, so tangent theta is always equal to opposite over adjacent. So tangent theta, next step here, I'm going to sub in the actual values in this triangle. All right, so for the opposite side, it's a length of 8. So in this case, it's going to be 8. Sorry, go. There we go. 8 over. All right, so my opposite side is 8. My adjacent side is 3. All right, so I have 8 over 3. Sorry about that, took a little longer. All right, so this is how we set up the equation. All right, so tangent theta is equal to 8 over 3. So I subbed in the values for the opposite side and adjacent side. All right, so to figure out the value of the angle theta, what we need to do here is something called a tan inverse. All right, so tan to the -1. This is just notation, all right, to find the actual angle. So I'm going to write tan inverse bracket 8 over 3. And so with your calculator, we should be able to figure out what this angle is. So I'm going to open up a calculator here. So for all scientific calculators, you should have these trigonometry buttons. So first off here, I'm going to punch in 8 divided by 3. And that turns out to being 2.6, blah, blah, blah. And then to get the actual angle, right, is I'm going to hit here trigonometry. There should be a shift button or a second button on your calculator. So I'm going to hit that, hit tangent inverse. So notice that it's when I click this, where I don't have a click on, it's just tangent. I click this in, it says tangent inverse. This is what I want. I'm going to hit that. And this value here is the actual angle. So it's going to be 69.4 degrees. So the measure of that angle So this angle here turns out to be 69.4 degrees. All right. Cool. So let's try another one. I'm going to go through this one a little bit quicker. But this time we want to determine the measure of angles K and N to the nearest tenth of a degree. All right, so in this case, we actually want to find both. Okay, so but to start off with, I'm just gonna, it doesn't really matter which one you find first. For this case, how about I find out angle K first, all right? So if I'm working with angle K here, this turns out to be, the 9 is my opposite side, 13 is my adjacent side, right? Because across from the right angle, this is the hypotenuse. Okay, so for this to find out the measure of angle K, I'm just going to write tangent of K equals, and remember it was opposite over adjacent. So if I plug in the values here, tangent of K is going to equal 9 over 13. Therefore, K is going to equal tangent inverse of 9 over 13. All right, so let's plug that in and find that angle. So 9 divided by 13 equals 0.6923, and hit second function tangent. And it turns out to be 34.7 degrees. All right. Now, to find angle N, which I will change the color of my pen here, let's go with green. So if I want to find angle N here, now this side turns out to be my opposite, and this is going to be my adjacent side. And again, the hypotenuse stays the hypotenuse. Okay, so over here, if I set that up, I got tangent of angle N is equal to, again, opposite over adjacent. The tangent of angle N is going to equal, so my opposite side in this case for angle N is 13. And the adjacent side now is 9. So notice that the fraction actually just gets flipped when I'm using the other angle. So N is going to equal tangent inverse of 13 over 9. So therefore, let's punch that in our calculator. So 13 divided by 9 equals 1.4444. Second function, tan inverse, 55.3. So as a result, I think it was 55.3 degrees. That is the measure of angle N. Now, there is actually another way I could have found angle N without using tangent. So the other way is to realize that the angles in a triangle add to 180 degrees. So I'm just going to write here another way to find angle N is to use the fact that angles in a triangle always add to 180 degrees. So yeah, so angle N in this case is, you might prefer this method, actually it's a little quicker. If I take 180 degrees and subtract the 90, that's one of the angles here, that's the 90 degrees here, minus the 34.7 degrees, which is angle K, this should give me the same answer. Right, so let's just make sure that works. All right, so all right, so 180 minus 90 minus 34.7. And you'll see that, yes, we get 55.3 degrees. which is the same answer as when we use the tangent ratio. All right. So there's two ways to find the third angle of a triangle. Either way, we should get the same answer. Cool. All right. So I think there's one more example here. All right. So for this third example, it's a kind of a word problem. We got to draw up a diagram and find an angle. All right. So a support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It is attached to the top of the pole. What angle, to the nearest degree, does the cable make with the ground? All right, so a lot of words here. Let's just start off by drawing a picture of the situation. Right, so here's the ground. And basically we have a telephone pole. And the support cable is anchored 5 meters from the base of the telephone pole. So there's a cable here. This is 5 meters. The cable is 19 meters long. So 19 meters here. What angle to the nearest degree does the cable make with the ground? All right, so this is the cable again, blue, that's the ground. So we want to find this angle here. So actually, first thing here, a little bit of terminology. This angle, we're looking up, or looking for an angle that's created with a horizontal. It's called the angle of inclination, but it also has another name to it, or elevation, angle of elevation. So you may hear this later on about the unit. Angle of inclination or angle of elevation, they both mean the same thing. It's basically the angle from a horizontal and then up. Okay, so we want to find that angle. All right, so if we're working with this, we can assume the telephone pole goes straight up down with the ground. So we can assume that this is 90 degrees. All right, so if I was to label the sides, this is my hypotenuse because it's across from the 90 degrees. This is my opposite side. This is my adjacent side. All right, so this question here actually is a little different from the other two because we actually are not given the length of the opposite side. Right? We're only given the length of the hypotenuse and the adjacent. So in this case, what we're going to have to do is we're actually going to have to find the length of the opposite side first. So step one, we need to find the length of the opposite side. All right, so to do that, whenever you're given two lengths of a right triangle, we can find out the third length by using Pythagoras. So Pythagorean theorem. All right, so the Pythagorean theorem, a squared plus b squared is equal to c squared. Now, the key to this Pythagorean theorem is that the c here is always our hypotenuse, and the a and the b are the other two sides. Okay, so in this case here, it's a different. This is actually the c, hypotenuse is c. I can call this a, and I'll call this b. So those are the sides in this this formula. So if I was to sub those into the formula, right? Again, my opposite side is what I'm trying to find, so I'm just going to leave that as a squared plus. All right, so b is equal to 5, so that's 5 squared equals c squared, which is 19 squared. All right, so what I need to do here is I need to find the length, solve for a here. Okay. So first thing I'm going to do here is I'm going to find out what 5 squared is. Well, that's 5 times 5, which is 25. So this is going to equal, this is the same as a squared plus 25 equals 19 squared. So the 19 squared, that's 361. All right, so to solve for A, what we need to do next is move the 25 over to the other side. So I'm going to subtract 25. So I get A squared equals 361 minus 25. That's 336. And therefore, A is going to equal, so the opposite of squaring is the square root. So it's going to equal the square root of 336, which is equal to, so we're going to round that. I'm going to round it to 18.33. All right, so as it turns out, that's our first step here. This length here is 18.33. All right, so I'm just going to redraw the triangle rather than keep scrolling up and down. All right, so again, this was 5 meters. This is 18.33 meters. The hypotenuse was 19 meters. I'm trying to find this angle here. All right, so next up, let's just label the sides here. So that's my 90 degrees. So this again is the hypotenuse. Across from it here is the opposite side. This was my adjacent side. So if I set up the equation, so step 2, set up the equation. All right, so, and again, I'm going to call this angle theta, the variable. So tangent of theta again is equal to the opposite side over the adjacent side. So tangent theta is equal to 18.33 over 5. Okay, so let's punch that into our calculator. Actually, you know what? I'm just going to leave this in here. 18.33. It's got a whole bunch of different decimals. Divided by 5. All right, so 3.666 dot dot dot. All right, so theta equal tan inverse 3.66 dot dot dot. And let's figure out what that angle is. All right, so this number here, I want to find the tangent inverse, so second tangent. And as it turns out, it's 74.7 degrees. All right, so that would be the measure of this angle here. All right, cool. So that is the tangent ratio. All right, the first lesson is trigonometry.